Conformance is a term used in object-oriented programming to describe one or more interfaces or sets of interfaces that match up with each other. This description covers one class conforming to another class, interfaces conforming to other interfaces, and parameters conforming to receiving parameters. Generally speaking, inheritance rules ensure that superclasses conform to subclasses because all of the methods of superclasses are defined in the subclass. Where conformance is concerned, the netcobol for .NET compiler enforces conformance between interfaces and objects. The compiler checks to see that any arguments that are passed to a method match up with the parameters specified in the using phrase of the procedure division header. Now, we've talked a little bit about this before, but it bears going over again. When we talk about parent, child, sub, and superclasses, we're actually talking about a concept called inheritance. In the real world, just as a child inherits certain traits or characteristics from a father or a mother, so it is with the parent, child, super, and subclasses, at least from a conceptual perspective. In the object-oriented programming world, you can see similarities. Subclasses are more specialized versions of a class, which inherit or can inherit attributes and behaviors from their parent classes. And of course, that child or subclass can introduce their own attributes and behaviors. Each subclass can alter its inherited traits. Subclasses can also add new members. Now let's talk about polymorphism. Polymorphism is a term used to describe using the same method name to perform different operations on different objects or in different circumstances. You're probably scratching your head right now, and to be quite honest with you, I don't blame you. So there's been a lot of confusion with regard to this term, and it is in fact a fundamental concept for object-oriented programming and object-oriented development. So let's try to understand what this is all about. Polymorphism is a concept that can really bring efficiencies in coding. For example, one line of code can request similar functionality from several different objects depending upon the circumstances of when the line is executed. And I know you're still scratching your head, so let's try to bring this into a real-world scenario. As I indicated before, a lot about object-oriented programming is concerned with taking the concepts of programming and equating them to real-world situations. Polymorphism is simply the characteristic of being able to assign a different meaning or usage to something in different or various contexts. Specifically, the concept of polymorphism allows an entity such as a variable or a function or an object to have more than one form. Polymorphism is really a pretty simple concept that is actually prevalent through life. Let's take a real-world example of this. Let's talk about humans or a person. A person is a base type. Let's say you are a more specific representation of that base type. We call it person. There are many people that inherit that type, and you're a concrete implementation of the type person. You have your own beliefs, your own attributes, qualities. All of those things go beyond the general concept of person. So, for instance, we all have a blood type, a shoe size, and so forth, different hair color. Each of us adds our own implementation of the person interface. Now, some of you may still be having a bit of a problem with this one, so let me try a bit of a different example. Many of you drive an automobile, or at least understand what an automobile is. So let's consider the automobile as a base type, and this type has properties like wheel size, engine size, gas tank size, and it may have still other properties. The automobile you drive or ride in is a concrete implementation of the automobile interface. It may have additional features like sliding doors or 2 doors or 4 doors. It may have a manual transmission or a moonroof, or it may have different colors. Things that are specific to that make and model of a car. In addition, an automobile may have certain behaviors like the ability to open the trunk from inside, or it may pop the gas tank door open, or may have still other behaviors that are specific to a given type of automobile. In object-oriented programming, using the automobile example, automobile would be considered to be a base class, and each automobile manufacturer would have its own implementation. So let's talk about engines, for example. For instance, Volkswagen may have an automobile with a turbo diesel engine. Ford may only implement their automobile with gasoline engines. Other automobile manufacturers may implement flexible fuel or hybrid technologies as an option for their engines. But the important thing to remember here is that there can be many, many more levels of detail or forms in which the implementation is set up for automobile. Now keep that concept in mind. In the programming world, you could have a method called save data, and that would be defined for several different objects. The method would have the same general function to save the contents of an object, but may differ in the details of the data and the format used to store the data to disk. So why is it that we do all of these things? Well, the fact is that this particular technique can bring considerable efficiencies in coding to your various applications. One line of code can request similar functionality from several different objects, and the implementation or behavior can all differ depending upon the properties or circumstances of when the line of code is executed. Simply put, an enumeration, or enum, is a symbolic name for a set of values. Enumerations provide a convenient way to work with sets of related integer literals and to associate constant values with names. The enumerated type defines a group of integers that can be referred to using a name such as system.dayofweek. In this case, the days of the week are represented as numerical values corresponding to a day of the week. The repository paragraph contains information about names that are defined in separately compiled programs or assemblies. This includes class names, property names, field names, interface names, program prototype names, delegate names, method identifiers, and of course enumeration names. The repository provides your COBOL program with all of the necessary visibility into external classes and provides what is essentially a collection of information about those classes, its functions or methods and properties. The repository is essential for building up the interface between your COBOL program and the .NET framework.